Okay, good afternoon, good morning. Today we'll be discussing routing concepts. As you would have noticed, course yedu yeCCNA inonzi routing and switching, basically. I think it used to be called routing and switching. They changed it a little bit. Yani wireless essentials, yani automation and all. But basically, it is routing and switching. Right, so for this one, I'll be focusing on the routing concepts. And this is the foundation of all the protocols that Shazoita, specifically for CCNA OSPF. We're going to be doing OSPF, which is a dynamic protocol. It's also the foundation for other type of routing that in static, for example. We are going to be doing static configurations, static routing configurations, right? So to go through this one, we have to begin. Let me see. We'll discuss path determination, path forwarding. How does a router perform those duties? And I think basically a router has two functions. One, to determine the best path. Packet trigger per router, the router determines what is the best path out of the router that is the destination network. So we have determining of the best path and forwarding of the packet. Those are the primary functions of the router. Those are the first things that you're going to discuss. Then we'll discuss basic router configuration, IP routing table, static and dynamic routing. Right. So basically, that is everything that we're going to be discussing, starting quickly with path determination, right? Functions of a router. So when a router receives an IP packet on one interface, it determines which interface, let me remove this. All right, it determines which interface to use to forward the packets to the destination. The interface that the router uses to forward the packets may be the final destination, or it may be the network connected to another router that used to reach destination network. So basically, we might have something like this. Let me see. Can I draw? Right. Let's have a very small network to help us explain all this. Right. We have a small network like this. Right. We have a LAN here. We have a LAN here. So this is LAN A. This is LAN B. Right. What is routing basically? If I have a PC1 here in LAN 1 and I have a PC2 in LAN 2, and I want to send information from PC1 to PC2, what this router knows in its routing table depends on what this router knows, and what is in this routing table depends on the routes that are configured on this specific router. It can be static, it can be dynamic. If we go and look at the routing table, has it been mentioned yet? The routing table, that is where we can all see, that is where we can see if we have a routing table for this one, routing table, that is where we can see kuti routes are defined, are configured. Anozikanwa nerouter, let's say this is router 1, this is router 2. Anozikanwa router 1 up. So each network that the router connects to typically, no. The interface that the router uses to forward the packet may be the final destination. I can have something like this, and I have PC2 here. This can be the final destination. If a PC1 wants to send to PC2, packet parinosvika pa this router, this is a directly connected interface, directly connected LAN. Router forward directly to PC2. That is a directly connected network. I want to show the difference between a network connected to another router. A network connected to another router, we call it a remote network. So if a PC1 wants to send, let's change this to PC3, wants to send to PC3, in this case, This is a remote network because it is connected to another router. So information ichabva PC1 yoenda parouter yozosvika kuPC2 to PC3. I'm going to be elaborating a bit further on nyaya directly connected networks indirectly connected networks, but this is just the introduction. Hope and explanation zvakawanda bekutanga. Let's go bit by bit. Right, each network that a router connects to requires a separate interface, but this may not always be the case. So I think this is a separate network, this is a separate network. For every interface per router, we have a separate network. Right, but with introduction of VLANs, that may not be the case. Because in the end, guys, a switch panel. There's some VLANs, VLAN 10, VLAN 20, VLAN 30. These are separate networks as well. So every interface on the router does not always represent a different network. Sometimes it's multiple networks that are attached on one interface in the case of VLANs. So this is the statement like when we started, every interface per router we said is a different network. But now takaita VLANs, every interface, not every interface renoita one network. Sometimes panenge pane multiple networks, and that is the case yema VLANs. The primary functions of a router are to determine the best path to forward packets based on the information in this routing table and to forward packets to their destination. So we already mentioned that the primary function here router, one, path determination, determining the best path, determination, the best path. Panogonoita mapath akawanda stereko, but the router has to know what is the best path. Nzira dzekuenda kubulawayo dzakawanda, but pane isina mapoto, pane ne road yakanaka, ine highway yakanaka, pane yekuti tikatora tokurumidza kusvika. Let me say, zvinhu zvatirofana kuita kukurumidza kusvika kubulawayo basically. So you have to choose road yakanaka yekuti inokurumidza kusvika kubulawayo. So router, it determines the best path repacket kuti risvike kudestination yayo, depending nekuti in between the source and the destination chii chiripo, pane congestion here, bandwidth yemaports yakaita sei, speed yemaports yakaita sei, everything. Right, so path determination, and number two, forwarding. After I determine that path, it needs to forward the packet. And basically, those are the primary functions of router. Right, router functions example. There we have a typical network. I think that was what I was trying to explain. We have a typical network at NIO, and this is our routing table. All right. For router pedu, if we have the command show IP route, I hope you can see this is black. There's a command right here. I'm going to show IP route. The command is going to show our routing table. Right. So from the routing table, I can see when a packet is over a PC, let's say PC in this line, you're going to have PC in this line. If I look at the routing table not only that we have a static configured route, Ruva destination 192.168.3.0, which is the destination of this network, right? And this is an administrative distance. Then this is the address of the next hop. So basically, the information in the routing table inokudza kuti network yauri kufanira kuenda ndeipi, uri kufanira kuenda sei kunetwork ikoko, network yauri kufanira kuenda ndeipi. So this is the destination network information iri parouting table, right? And uri kuenda nekupi, let's say this is the exit, no, this one is the next hop. Let's say this is the next hop. Next hop meaning the IP address of router rauri kuenda after that. Right, so the next hop address is this address iri panapa. So information routing table basically zvainokudza ndezvekuti packet rasvika parouter rotarisa destination address yayo packet mune source IP mune destination IP. Router rinotarisa destination IP yonoti network ipi, yaunoti network ipi yotarisa routing table yayo, yonoti routing table yayo network yakafanana ine packet rarodosendwa ndeipi. This is the network, the destination network. Then yoona kuti packet rinobuda nekupi kuti riende destination network, and this is parobuda nepacket. So this is a brief of how routing is being performed. Packet rasvika, routing table yotariswa, potariswa kunzi best match, and then tichasvika kwama-best match. Best match yeaddress nezviri murouting table yakaita sei. Then what is the exit interface? Packet richabuda nepapi. At times this interface, exit interface is configured. At times the next hop address is configured. Right, just depending the way you configure. Right, briefly, that's how routing is performed. Right, best path equals longest match. Here, so what the routing table is, let me go through this first. The best path in the routing table is known as the longest match. The best path is known as the longest match. The routing table contains routing entries consisting of the prefix and the prefix length. For there to be a match between the destination IP of a packet, a minimum number of far left bits must match the address of the packet and the route in the routing table. The longest match in the routing table, that is the greatest number of far left, right? They're just repeating the same thing. So the routing table, what is the routing table? Let me start with what is the routing table. It's a database that is all the routes of all the networks are in, let me say, a database of all the routes or all the networks are in the big network that we have. We might have small networks which are lines in our wide area network. So the IP, the routing table, it contains what are the routes of all those networks, basically. Right. And with respect to matching, if I have an IP address, let me explain with respect to matching. If I have an IP address, right, this is the destination IP address that I have. I want to send a packet to this destination IP address, 172.16.0.10, IPv4 longest match. And I have in my routing table, I have routes, my routes are in one, right? I have 3 my routes and a different my prefix length, 12, 18, and 26. Right. One of the ways a router knows could I have to take which path first. We have other ways that Chazo discuss kumberi, atinoti my matrix, my hop counts, costs, nyanza bandwidth. We have atinoti administrative distance, lowest administrative distance, no path no choose first. For example, my directly connected always. Interface really directly connected to the router. Ndo choose first kana riripo pa routing table. I think statically configured route ndo choose after. Then we have an OSPF which is choose kumberi, an RIP which is choose kumberi, depending on that. But we have not longest match. This might be the starting point. Longest match, doing no starting point. So what is the longest match? This is the destination IP kurufana kuenda packet. If I look at the routing table, I see what how many bits from the routing table are matching my destination IP. How many bits from the routing table are matching my destination IP? So if you have a /12, it basically means 12 bits will match with this address. So if you take a look at address E in bits, in binary in bits, this is the address we have 172.16.0.10, and in bits, yakaita like this. And if we take 172.16.0.0 in bits, yakaita like this, this, respectively, 12, 18, and 26. And if we try to match, you see this one match after only 12 bits. Because in one network ID, so after only 12 bits, doba no measure like this. So the first one in a 12 bits are measure. Because after that, that is the host portion no change. If we have 18/18, we got 18 bits, So this is 8, 12, 16, 18 mabits kusvika panapa ndo anomecha. So this is root number 1, this is root number 2, 18, then rimwe rine 26, pese apa pane pakamecha apa 26. So by definition, root rinopikwa is the route rine the longest match. And the route rine the longest match panapa iroute rine /26. Route rine /26 ndo rine the longest match. Among maroute esa they won't be chosen, but kana iri rine 26 risipo, it means rine 18 ndo rinopikwa first, ndo kuno forwardwa packet redo. So basically that is the longest match example. But you see as we go, this is not a big deal. Tine mametrics anoshandiswa, tine ma-administrative distances anoshandiswa to choose with the best path iripi. But starting point, obviously, is the longest match example. Right. Number 8, the longest match example. So the one yanganishitengeri IPv4 is the same thing for IPv6. Almost the same thing. Right. Here we have an address. This one, this is the destination IP address. Then tinema route edu 3 rapa. Right. For this one, right, C000. For this one /40, it means 40 bits in those measure. Because if you look at this DP8 C00, it matches everything. Chiripa destination IP address here. So all the 40 bits, zipa route number 1, dzinopikwa. Tikaenda route number 2, all the 48 dzinopikwa as well, because ASR apa ari kumecha the destination IP. Version 6, obviously. Then if you look at the third one, it's not matching per 64, it's not matching because after 2001 DP8 C000 pane 555 panapa. 55 panapa panapa, but destination IP panapa. So it's not matching. So this, it will not be chosen. Even if prefix length here is 64, ukashandisa logic yepatabva apa patati 12, 18, 26, tashandisa 26 prefix length, which is the largest. Panapa ishande because pane a difference in the destination IP v6 and the route ruvanopikwa. So route number 2 here, ndo rine longest match. So what we're just doing is we have, let me explain with this. With version 4, it's much easier. So what we're just doing, you look at the left side. You start comparing from the left. Kuti mabits akafanana destination IP neroute yako ndeapa. And you see my destination, mabits anofanana paroute anogumira panumber yeprefix length. Why? Because the network ID does not change. After that, it changes. So we don't consider Zulumberi because host rinogona kuchinja at this level. Longest match, IPv4 longest match. Right. Quickly moving on to what is this? I cannot see properly. Let me move this. Right, path determination, build the routing table. Building the routing table. Right. So the routing table can be built mainly by 2 ways. Statically, which means you're manually configuring my networks, my routes, you are manually configuring them, or they are dynamically configured, which means you have my routing protocols information with we have a new network and what is the administrative distance uskako irushanisa protocol ipi, etc, etc. 2 ways of doing that. Right, we have what we call directly connected networks, remote networks. I think I've explained the difference between these two. A directly connected network, if I have a small network like this, 2 routers, right? Okay, 2 routers, we have a LAN here, we have a LAN here. If I go to router number 1, directly connected network is the router number 1 is this LAN this interface, this LAN is a directly connected network because it's directly connected to router number 1. This, with respect to router number 1, it's a remote network because it is not directly connected to router number 1. Basically, that is the difference between directly connected networks and the remote remote networks, right? Nyaya static configurations dzema routes dynamic configurations dzema routes. Static configuration, when you are in a very small network, I can easily say I can configure network iri apa statically. Ndinoyapa router yangu iyi. Router yangu ndoiudza kuti ukabudisa packet via this exit interface, this one, then inokwanisa kusvika panetwork ishi, because rikangosvika parouter 2, router 2 rinoziva kuti pane network inonzi LAN B. Router 2, LAN B is directly connected to router 2, so router 2 inotoziva kudaro. But the router 1 haizivi kuti kune network iroku. So how does it know? You can configure panap oudza router rako kuti if you exit using this interface unosvika parouter 2, then ukasvika parouter 2 you definitely know kune LAN B iriko. That is static configuration, manually configuring. But when you have a very big network in a router 1000, you cannot go from a router 1000 which is some manual configurations ema routes ese. You need my protocols to help you with that. So my protocols anenge share information kuti nini router number 1 ndine directly connected networks akati information iyoyo yasendwa kurouter number 2. Router number 2 otora information oti ndaudzwa narouter number 1 kuti ari connected kuningi. Saka kana muroda kuconnected to network yakati, ini ndikuziva kuti router 1 ari connected to that network, then ndokwanisa kusenda kurouter 1. Router 2 also does the same with another router, also does the same with another router. Protocol is a way my networks communicate. Anenge achisenda my messages between each other. And that's how my routes are learned. Router rinongoziva kuti inini ndine directly connected interface yakati. Yobva yasenda information kune imwe router. Imwe router yobva yatoziva kuti router number 1 riri pakati rine ma directly connected akadai, yosendawo kune mumwe. And after convergence, every network yako inenge yakuziva kuti packet rikangouya rinofanira kusendwa kupi. Right, default route. Let's talk about the default route. Let's say you're in a network and packet router sender address yacho, the destination network, is not within your local network. For example, pamuno browser, when you browse muchisenda if you request per Google, information your request per Google doesn't come from your local network. You know, say for a Google, probably tier 1, which is okay, but say for a Google, I think really go USA. Right? How does your router know route network USA? It probably doesn't. Right? So pono sender information yako paka local area network yako pana. Let's say we have ISP kuno. Pono sender, pono request panapa. Router rako haritombozive kuti information inofanira kuenda kupiyo. And parino process a packet richitsvaga ma longest match, hapana longest match yainowana. Kana pasina inonzi default route, packet rinovhara drop because hapana kwari kufanira kuenda. But the default route rinoisirwa kunzi kana pama packet rashayikwa kunzi riri kuenda kupi, definitely riri kuenda kune inonzi default route. And you see kuti default route yedu kakawanda kacho inenge yairi yaconnectwa kuti iende kuna ISP. And ISP ndiye anozoziva manje kuti Google iri kupi, ndiye anozokwanisa kuresponda ozodzosa information yeGoogle. But kana pasina ISP, uri munetwork yako yakangodaro local area network yako isina ISP, packet roshayikwa kunzi match yayo ndeipi, that packet will be drop. Ndo the use yema default route. So you see the default route rinenge rine address 00000, which means every address yaunoziva can be matched to this address. Every address, it can be matched to this address. So kana yashaya inomecha, it will definitely match with this address. Then ndo kunosendwa packet go, which is usually via the link rinoenda kuna ISP, default route. Right. Packet forwarding. After the processing, basically, zvangatiruta longest match, that is the processing part. Packet rufana kwenda kupi. we have what we call packet forwarding, right? With packet forwarding, now taziva kuti tiri kuenda kupi, takufanira kubudisa via the egress kuti riende destination, and there are ways how we do that. Briefly explained in five ways here, right? The data link frame with an encapsulated IP arrives on the ingress port. The router examines the destination IP, consults the routing table. The router finds the longest matching prefix. Router encapsulates the packet in the data link frame and forwards it to the egress. However, if there is no matching route entry, the packet is dropped. If there is a default route, it is not dropped, send or default route, right? So what we have, lani yedu PC1 muno. PC1 asenda information yake router. Yasvika router, inosvika ingress port. Router rovhura frame. Frame ndo mune packet. Packet rotariswa destination IP. Here we are. Destination IP yedu yakaita sei. Yobva yanomecheswa kurouting table. Yamecheswa kurouting table. Kana kusina match, it gets dropped. Kana kune match, iro rakunoencapsulatewa. Match yawanikwa rakuencapsulatewa again kuti ribude murouter via the egress riende destination yayo or the next hop address. That is the next route. Just depending nekuti the next network or the destination yari kuenda ndeipi. And basically that is the forwarding process. Deencapsulation, pekutanga pana deencapsulation yeframe rikuya rotariswa IP address ponomecheswa tonoona kuti rinomecha here, kana pasingameche rodropwa, kana pachimecha tonoona kuti riri kumecha neaddress ipi, then tonoita encapsulation. After encapsulation yakuenda kwainofanira kuenda the destination device or the next hop route. The process of forwarding a packet. Right. Let's go to forward the packet to a device on a directly connected network. Right. Number 2, forward the packet on the next hop route. Right. There is a small difference between forwarding a packet to a device on a directly connected network and forwarding a packet to a next hop router. Right. Let me use this to explain. Number 12. All right, let me use this to explain two networks. All right, PC1, here we have PC2, another LAN. Here we have PC3. All right, if I'm sending a message to PC3, the process yatabva noexplaina yeforwarding, iro frame rinosvika parouter rovhurwa, destination IP yotariswa, poitiswa match, yononzi match inofanira kumecha nenetwork iri kuenda kupc3. Okay, rakufanira kubuda kuenda kuegress. How do we encapsulate it? Rakuda kuencapsulatewa rakuda kubuda panapa. Encapsulation here ndo panoda understanding yeOSI model need the process encapsulation. Trim layer 3 ipacket ndo richaencapsulatewa kuti riite layer 2 data link frame. Ndo panoitika encapsulation. Packet rubva murouter richada kuencapsulatewa kuti riite layer 2, then rozodzika rozofanira kusendwa. Encapsulation yatirimo consent nayo ndeye panapa layer 2. Now kuti tiite encapsulation at layer 2, we need the MAC address. Kana tisina MAC address, ndo panopinda the process yeARP, address resolution protocol. I think so. Yeah, I think so. Ndo panoita protocol yeARP. ARP is used to match tine IP address already, destination IP address tinayo. We don't have the MAC address. So at this stage, router it either looks at this ARP table or cache, yotsvaga kuti ndine IP yakadai so, IP address yakadai so, what is the MAC address? Kana musina, ARP request yosendwa broadcast, PC3 yoresponda neMAC address yayo. Kana takuziva MAC address, then we can encapsulate layer 2 toisa source MAC destination MAC so that device redu receive information yayo. Right. So that is what is being explained panap. To encapsulate the packet in the Ethernet frame, the router needs to determine the destination MAC address associated with the destination IP. The process varies based on whether the packet is IPv4 or IPv6. So with IPv4, we have ARP. With IPv6, we have neighbor discovery, ICMP-v6, NT. So both these processes are used to resolve ndine IP address yanenayo but andisikuziva MAC address. Router parinoita framing yepacket yayo, it will need that MAC address. This is where the process takes over. So you see everything zvataita kumashure, I think it starts linking up here, zvichibatana, building up, level of understanding yedu ichikwira zvichienda. Right, forward the packet to the next hop router. Right, I think it's the same process. Example yanga tatanga nayo PC1, PC3. Here we have a directly connected network. So tinongo request kuti MAC address PC ichi to send. In this case, we request the MAC address here, this interface. Let's say today send up PC2, which is a remote network. So PC1 pano is a packet rayo panap. This one analyzes yotsvaga longest match, you're not longest match, irofana kuenda via this exit interface ichienda pa the next hop route. Next hop router address ichi tinenge tinayo but tinenge tisina MAC address. MAC address toiona sei router rinotsvaga mukashe ARP table or kana iri IPv6 inoita neighbor discovery is yoona kuti what is the MAC address. Kana musina, it sends a broadcast iri reply kuti MAC address yangu ichi, then encapsulation at layer 12 yaitwa, frame rover rasendwa, rikasvika panapa same process yatamboita panapa tichienda pa PC3 yoitika, ARP table motariswa, kana musina request yosendwa, information yosvika ku PC2. Packet forwarding, decisions, etc. Right, let's move to drop the packet. This is obvious. Packet can no match, it gets dropped, but we know it's wise that you don't have my packets are not drop over network per network. Always have a default route. Kuti zvikasa-drop zvinoenda zvobuda zvoenda kuinternet, zvoenda via ISP, zvikashaya ikoko ndokwazvinodropero. Right, end-to-end packet forwarding. The primary responsibility of the packet forwarding function is to encapsulate packets in the appropriate data link frame type. Right, here we'll talk of, let's give another example of a network. Tutaura nyaya dzema-types ema-data link frame types. Let's have a network like this one. Router, we have another network like this. Right. So this is PC1, this is PC2. If you look at network yedu ndine iri, it's probably a link Ethernet here. Right? Pan Ethernet port panap, Giga Ethernet, Fast Ethernet, Giga Ethernet, Fast Ethernet. If you look at link iro, is serial. It runs point to point, akasiyana malink one. Right? One in Derema LAN, this one in Derema wide area networks here, Derema wide area networks. Right, so internet two different links ziri up. Malink wayo ane two different types of data link framing. If you look at Patakata CCNA 1, we talked of the Ethernet frame. We talked of the Ethernet frame because they deal nema Ethernet links. Tansata shika kuma wide area networks here. They deal nema Ethernet links. So we talked of the Ethernet frame. At no matter a serial frame or anything like that. So you see kuti framing, ndikasenda something panapa, chikashika panapa, this interface, chiruda kuendeswa kunoko. Panoitwa Ethernet framing, which we are familiar with. But chikashika panapa, chakudo fura pa point to point serial